few months ago, I was contacted by Nick, who goes by Saint Nick, I think, on Instagram or TikTok, and he's an electrical engineering student somewhere near Chicago, Illinois, and he contacted me through Energetic Forum and said he is working with somebody named Parker, who is a magnifying transmitter that he's experimenting on a certain frequency, and he said that he had a receiver coil tuned for it up in Chicago, and it's making his LED light blink. So we'd like to see more testing with this, but if you go to look at some of the videos that he's going to be Parker's going to be sharing with you, you're going to see that he's really ambitious. He's very, very smart, very, very talented, extremely passionate, and he does all kinds of stuff that really kind of revolves around the late 1800s, early 1900s era, everything from playing music to singing these old-time tunes and restoring old equipment, building this Tesla kind of stuff, installing a gas light system in his shop, these big Frankenstein knife switches with this big pole pig transformer out in the yard, and a lot of sparks and a lot of fun. And he has a TikTok channel that has over 800,000 followers. Interestingly enough, just a couple nights ago I was going to send some traffic there and it mysteriously disappeared. Interesting timing. Parker goes by Dr. Parkenstine, and if you search that online, you're going to find all kinds of people reposting his videos on Instagram and everywhere else, and he's going to give you kind of a video walkthrough of some of his journey on this. And we'd like to thank his dad, Chris, who is kind enough to bring him up and take part in the conference and see what this is all about. So please help me welcome Dr. Parkenstine.
Okay, today I'm going to show you the effect the magnifying transmitter has on a fluorescent light bulb when held up in the air near it. I will also be showing you the receiving coil lighting the neon light bulb orange in the nighttime, in the darkness. Okay, here we go. That is completely wireless. So here is what was in the box. It is a Model 40 Atwater Kent radio from 1927. So I'm unsure if it works or not, but I will plug it in and test it. If it doesn't work, I can fix it. So here is the inside of the radio. It is missing 2 vacuum tubes, but they came with the radio, so I'll put them in. Okay, now all the tubes are in their right place. Now we'll connect the speaker, which is also from the 1920s. Now we'll connect an antenna and a ground to the radio. Okay, now everything is connected and I will plug in the radio. Hopefully it doesn't blow up. Okay, it's plugged in. Now we'll turn it on. Okay, today I'm going to be making a light bulb. Okay, so I found this reagent bottle in the laboratory and I figured it'd make a good light bulb. So I'm going to be experimenting to see which gauge of nichrome wire works the best. I'm going to start with number 26. So I cut different pieces of nichrome wire, all the same length but different gauges, and I have determined that 36 gauge will work the best for this light bulb. Here is the stopper I'm going to be using for the reagent bottle. I've placed 2 bolts and I've sealed them with wax. These bolts will hold the filament. Now I'm going to cut the filament out of this 36 gauge nichrome wire. Now I will light this small candle so it will use up all the air inside of the glass when I set the glass over this stopper. Now I will test the light bulb using this 6-volt battery. Now I will connect the light bulb and then I will turn the light out. So this result isn't going to be that great, but it was my first test run. I will show you several improvements I have made to the light bulb. One of the improvements I made was a better vacuum in the glass. So I turned the glass upside down and I have a lighter up in there until the flame went out. And then I put a candle on the stopper on the reagent bottle turned upside down and set the glass over it, and then the candle went out inside of there. Another improvement I made was I used thicker nichrome wire. I used 22 gauge nichrome wire. And the third improvement I made, since I used thicker wire, is I got a bigger power supply, so it's more voltage and more amps. So this power supply converts 120 volts AC from the wall outlet to 12 volts at 30 amps DC. Now I will connect the power supply to the incandescent light bulb I made, and then I will plug it in with the light on. Okay, I'm going to plug it in and turn off the lights now. Okay, today I'm going to be showing you my ultraviolet ray oscillator from 1919. So I believe the box is made of quarter sawn oak. I'm going to open it. Again, you're wrong, and to the throng I'm going to introduce. Oh, Barney Google with a googly eye. Here are the original instructions for the ultraviolet ray oscillator. It originally came with an electrode like that. Barney Google with a googly eye. Barney Google with a googly eye. Barney Google. You may pause the video here to read this. So it works off of 110 volts AC or DC. Now we'll plug it in. Who's the greatest lover that this country ever knew? And who's the man that Valentino takes his hat off to? So originally this would have plugged into a lamp socket or screwed into a lamp socket instead of had the plug on the end. Here's the other end of the cord. I call this the Back to the Future plug. So that's the spark coil, and that's like a Rumkoff coil, or however you pronounce it. Now we'll fire it up. Okay, today I'm going to show you the transmission of electrical power using only one single wire. Here I have two coils, and each coil is tuned to resonate at 168,000 hertz, or 168 kilohertz, or kilocycles. So on this coil, this would be considered the primary because you put power into that coil. And then on this coil, this would be considered the secondary because power comes out of this coil. So they're like transformers in a way. Okay, first I'm going to connect the bottom of the longer coils together, and then I will put the signal generator onto this coil, or the primary coil of this coil. Okay, when I reference a primary, I'm going to be talking about this coil, just to make it easier for this video. Okay, today I'm going to show you how to build a receiver coil from start to finish, all in one video. So here are the materials you will need. You will need at least 1,464.2857 feet of wire. I recommend buying 6,290 feet of 26 gauge magnet wire on eBay because it is $58. That's the best deal. Once you have wound your primary to a quarter of the wavelength of 168 kilohertz, you will want to tune your primary to resonate at 168 kilohertz. So to tune your primary to resonate at 168 kilohertz, you will need an oscilloscope. You will also need some sort of a metal object. I recommend using an empty soda can if you don't have a toroid like this. So here is a schematic explaining all the connections. Maybe this will explain it better. Here's the oscilloscope. Here's the 4 kilo ohm resistor, and here's the 1N34A diode. And there's the empty metal soda can, or toroid. Not only is the light bulb the brightest at 168 kilohertz now, by the way, the light bulb's on the secondary coil, not the primary. And But when I move closer to the coil, it detunes the coil and the light bulb will quit lighting up. That is why it's important to tune your coil with things as far away from the coil as possible. Nothing should be close to the coil, and it should be elevated off the ground. Okay, today I will be working on my magnifying transmitter. So it rained yesterday, so what I did to keep the tank circuit from shorting is I put the capacitors, or the commercial capacitors, on ceramic tiles. So if you have watched my previous videos, you'll know that my goal is to wirelessly transmit power on a global scale using the Earth as a conductor. Because at certain frequencies, the Earth conducts quite ideal. So my goal is to keep sparks down to a minimum, because sparks are wasted electricity and wasted energy. So what I have done, I put a lightning arrestor where the spark gap normally is. So ideally, the magnifying transmitter would be tuned to 168 kilohertz or 168,000 hertz, but it's probably not right now, and I haven't tested it yet because so many wires had fallen on the secondary before I came and fixed it that it messed up the tuning, but it's easy to fix with an oscilloscope and a signal generator. So I noticed in my previous videos about the magnifying transmitter in the comments that people think that one receiving coil built to receive the power from this magnifying transmitter will only power one LED light bulb. This is not the case. It can power many LED light bulbs on one receiving coil. Okay, here we go.
You know, who's so close to the real world, you know, instead of all this digital stuff. We appreciate you coming up, and thank you so much. Dr. Parkenstine.